Good morning / afternoon, depending on when you have my class today, engineers. Unfortunately, it was called for jury duty today. So jury duty calls and you have to go or they fine you. So what we're going to be doing today in this ed puzzle is going over that project that we were finishing the class with on Wednesday. And I'm going to give you kind of a chance to go over the notes again, because I know some people were like, oh, we went too fast. So I'll go through the notes, and then I'll also go through the actual code in the project so you get an understanding of this. And then there'll be some questions along the way to make sure that you're following along and you're understanding. So let's go ahead and get started with this project and the slides. Okay, so if you remember back from the notes, we talked about that we had a whole kind of list of new topics that we were going to have to learn. And I understand that there was a lot in there, but hopefully, after seeing it on Wednesday and then seeing it again today, that you'll have an understanding of all of these different functions here by the end of this video. So let's go ahead and get started with the first one, which is importing modules as other names. So previously we've talked about importing a full module. Another name for a module is a library. So if that's an easier thing for you to remember, a library which contains lots of books, lots of tools, module, library, those are your toolboxes. So those are kind of the bins that store lots of the functions that are all related to each other. And then we have the individual function import. So that was if you only needed one tool from the toolbox and you didn't want to have to refer back to the toolbox name or the library name every single time, then that was the syntax for that import. And then the thing that we learned in class on Wednesday was importing that entire module, so taking that whole library, but doing that with an alias or with a new name, so we can kind of shorten the name of that module. So if we're looking at our code, let's go ahead and take a look at that. The first thing that we had to do in this importing libraries, it says here we need to import the sleep function from the time library. So that's the example back in the notes of the function import. So that's where we're going to do from the module name, import, and then whatever the function name is. Okay, so let's go ahead and do that. So we start with a from, and then the module name. So the module name is the bigger bin. That's the time library. And we want to import the sleep function. So that's what we did in this first line right here. We imported just one function from a library. So now we don't have to write time.sleep every single time. All we have to do is just write sleep when we want to use that function. Now the second type of import, this is the one where you have to use the alias, and we're importing the entire module or the entire library. Okay? So it says we also need to import the rpi.gpio. That's the name of the module, the name of the library, but rename it to GPIO to make using the function easier. So if we're doing that, and again we can look back at the syntax, we need to start with the word import, and then we have the long name, so that's going to be our rpi.gpio, and then this keyword as, and then we can give it the new name. And in this case, we want to give it that new name GPIO. So we're going to import the rpi, and it has to be spelled exactly like the name, so capital R, capital P, lowercase I, .gpio as just GPIO. And now we can use any of these functions that are in the GPIO or the rpi.gpio library by just writing GPIO dot and then whatever the function name is. Okay, so that again was just importing the libraries. So now we're set up, we can actually use all these different tools that we're going to need to do this project. So let's get on to the second topic, and that was when we were defining variables. So in Python, variables are just containers that store data, right? They're just a word or a phrase if you use underscores that are assigned to some data. And it doesn't always have to be a number. It could be a number, it could be a string, it could be a list, but it's assigning it to one name. And so the use in this project here was we had to connect our LED circuit to one of the pins on the Raspberry Pi. And if you weren't there on Wednesday, you're going to hear about what pins are in just a minute. But if you look, that LED circuit is connected to pin 9. And that's where we were, that's what we were using for the LED circuit project. So if we want to not have to use or not have to remember, because once we plug this in, it covers up that number, then all we have to do is just give it a name up front, and then we can just refer to it by that name every time we use it in the project. So instead of using a 9 every time, we just use LED pin. And then we can forget about it. It's like anytime we want to send a signal or send a light to the LED pin, we don't have to remember what number it is, we just put LED pin. So that's what we're going to do next in the project here. It says define a variable for the GPIO pin number that is connected to the LED circuit. So we got to give it a name, LED underscore pin. That makes sense. I mean, I could have just named it LED, but because we're kind of learning here and I want to get to the terminology down, LED pin sounds like a good name. All right, and then we need to set that equal to the number that it's connected to. And so in our circuit, it's connected to pin 9, so we're going to put LED pin equals 9. And now instead of writing 9, we'll just write LED pin whenever we need to refer to that pin in our code later on. Okay, so that was setting up getting everything set up. Now the next thing that we need to do is actually start to look at some of the GPIO functions. So if you're looking at the slides, or if you have your notes, I'm going to skip ahead just a little bit for a second and jump to GPIO. So GPIO is general purpose input output, and that's what makes the Raspberry Pi special. It has these 40 different pins that act as different inputs and outputs, and actually not all of the pins can be inputs and outputs. You can see that like some of them are just outputs. So like pin 1 is just 3.3 volts. It'll always provide 3.3 volts. Pin 2 is always 5 volts. Pin 4 is always 5 volts. It looks like 6 is always ground. But there are several. Actually, there's 26 different GPIO pins that we can actually program. And so with that, we can send signals and we can also receive signals from an environment. Now, in order to do that, you have to know how to use the GPIO functions. So when we imported that rpi.gpio library, that was giving us access to all the tools to be able to actually send and receive signals from these pins, but we got to know the actual, like the names of the tools themselves and how to use them to be able to actually blink lights and turn things on and off and read values from sensors. So a couple things with these GPIO pins. There are 2 different numbering systems. It's kind of unfortunate, but it's just the way it is. There's the board numbering system, which is just like the physical location on the board. And then there's a GPIO numbering system, because remember, there's only 26 out of the 40 pins that can actually be used as GPIO pins. So each of those 26 has a number, and that's the one that we're actually going to use. So for the GPIO numbering system, the actual technical name for it is BCM, Broadcast Management, BCM. So that is the one, Broadcom Management, I think, actually. But BCM is what we're going to be using for all of our projects going forward. So we'll never use board, we'll always use the BCM. All right, so let's get into some of those actual functions that we're going to need from this GPIO library. So if you are using these GPIO pins, the first thing that we're going to have to do is we're going to have to use this set mode function, And what the set mode function does is it just tells the computer which numbering system that you're using. So like I said, there's 2 numbering systems. We're going to be using the BCM numbering system. So all you have to do when you're using this set mode function is you just have to write GPIO dot, because it's in the GPIO library. Anytime you're using a function from a different library, unless you import it as a specific function, you need to refer to it as the GP or whatever the library name is first, and then dot, and then the actual function. So we're not just going to put set mode, we're putting GPIO dot set mode, and then we need to tell it that we're going to use BCM, and BCM is actually one of the functions as well inside of the GPIO rpi.gpio library. So again, we can't just put BCM, we have to put GPIO.BCM so that the computer understands we're referring to. It's not just 3 random letters, BCM. All right, so let's go ahead and get that filled in for the project. So if we're doing that, down here it says tell the computer which numbering system we are using. So to do that, we're going to have to go GPIO.setMode and then GPIO GPIO.BCM. And now the computer knows whenever we're giving a number that we're referring to the GPIO pins, and those are going to be the numbers that are actually written on the SMART module. Okay, so that is one of the functions that we're going to be using from the GPIO library. And actually, technically, it's two. It's the BCM and the set mode function. Okay, so after we've told the computer what numbering system we're using, then the next thing we need to do is we need to tell the computer which pins we're actually going to be using and whether or not they're going to be inputs or outputs. Because remember, GPIO stands for General Purpose Input Output. So it can be used as either or. You have to tell the computer what it's going to be what it's going to be used as before you actually get into using the pins. So to do this, it's another function. It's called setup. And because it's in the GPIO library, really it's going to be GPIO.setup after we renamed it. And there's three different arguments. An argument is just an input to a function. And the three arguments that you need are, first, it's the pin number that you're going to be using. And in this case, we're not going to actually write a number. We're going to write LED pin because we used a variable to assign that number to the variable. So we don't have to remember the number every time. We just know it's the LED pin. The second thing you need to do is you need to say whether it's an in or an out. And just like in the previous function where we were using the BCM, the computer doesn't understand just in or out by itself. You would need that GPIO.in or the GPIO.out in order to actually use the in and the out. And then the last thing is just the initial state that it's going to be in. And usually what we're going to do is we're going to set it in the low state. And again, just like in and out, we also need to say, because you can't just put low by itself, you need to say GPIO.low because this is in that GPIO library as well. And that's what I'm saying down here. These are both in and out. They're both parts of the GPIO library. So you have to give that tag in the front before you actually use it. All right, so if we wanted to do this setup, so you can see in this code, we've already imported. We've done the variable assignment, and we've done the set mode. The last thing here is the actual setup. So you can see we use GPIO.setup. First argument is the pin number that we are assigning. That's the LED pin. Second thing is how it's going to be used. So because we're sending that signal to turn on the light, it's an out. And then we're setting the initial state to be in that low. So let's go ahead and fill that in the project here. Down here we've got setup. And then first thing is this LED pin. So we've got the LED pin. Second thing is how we're going to be using it. So we're going to be using it as an out. And then the third thing is how it's initially going to be set. So when we start running this program, we want this to be in the GPIO.low state. And we know that in the low state, it's going to be turned off to start. So then, we're not randomly having this thing turn on. It's only going to turn on when we start the final statement here, which is our while loop. So let's go ahead and get into that last part here, which is the while loop. So this is actually kind of where we're going to be sending the actual signal to turn the LED on and turn it off. And then we can actually modify the sleep, and we're going to use that sleep function. We can modify the numbers inside there to make it blink faster or make it blink slower. So let's go ahead and check it out. Okay, so over here, let's go back to a few slides earlier. So this might be a little bit earlier in your notes if you were there on Wednesday. All right, so this is where we talked about the while loop. And while loops are something that in a computer science class, you could have multiple lessons on. We're really not going to have a ton of work with it, but in this project, we need something that's going to have our code repeat over and over and over and over and over again. And to do that, you can just use this simple while loop, which is called an infinite loop. And so an infinite loop is just a while loop where the condition is always true. And what that means is that if whatever is after while is true, then the code underneath it will run. So if you look at this example, it says while true, and then it's set off with that colon. This would continuously run. So it would print, this will be printed over and over again. It would print that statement over and over and over and over and over again until you actually stop the program or you shut down the computer. So a while loop, again, it just repeats the code over and over and over again if you put that true statement next to it. In future lessons, we're going to be using some logic to evaluate whether or not it should be running or not. But in this case here, we just want it to be continuously running. So we'll use the while and then the true condition here, and that'll make it run over and over and over again, which will make the light blink. So that's going to be kind of the start of this code. So we can go back to our project real quick, and we can start this infinite loop with a while true, capital T-R-U-E, and then set that off with a colon, and notice that it automatically indents the next thing down because that's what's going to be going on in here. So in this while loop, we want to use the GPIO functions to turn on and off the LED. Well, that's the one last thing that we haven't talked about yet, so we need to get to that. And the function that allows us to actually turn on and off an LED or send a signal, send a high signal or send a low signal, is the output function. And again, because it's a part of the GPIO library, when we're referencing it, we have to write GPIO dot output. And then this function has two different arguments, two different inputs. The first is the pin that you're going to be sending that signal, our LED pin. And then the second is going to be whether or not you want it to be high or low. And just like in the previous example where we're setting it up, high and low are also part of the GPIO library. So we got to do GPIO.high, GPIO.low. If we do high, it'll send a high voltage. If we do low, it'll send a low voltage. So if you're looking at this example here, we've already talked about all the setup. We've talked about the while true. So to get this to turn on, we would need to do a GPIO output, LED pin high. To keep it on, we need to give it a sleep function. So this will keep it on for 2 seconds. And then to turn it off, we would need this GPIO.output LED pin low. And we actually are missing a line here. But the last thing we would need to do to make it actually stay off would be to add another sleep function here at the bottom so it stays off for 2 seconds. And then it'll go back up to the top, turn on, stay on for 2 seconds, and then turn off, stay off for 2 seconds. On, 2 seconds, off, 2 seconds. So on and so forth. And that'll go on and on again until we stop the program or we shut down the computer. So let's head back to the program one more time. And let's write this final code. So again, the function is in the GPIO library. The name is output. And then we have to give it two different arguments. So one is the pin, so it's LED pin. And the second is whether or not it's high or low. So in this first part, we want to turn it on. So we got to go high. And then we want it to stay on. Let's just make it stay on for 1 second. So not too long. And then we got to turn it off. So another GPIO.output. But this time, it's the LED pin being turned to low. And then we want to sleep that one more time to keep it off for 1 second before it then goes back up to the top there. So that is it. That is your full program. And then to run it in Thonny, you have to click this run button. We would see that LED start to blink, blink, blink. And then if we wanted to stop it at some point, we would hit stop or just unplug the actual smart rover from power. So I hope that cleared things up for you guys. Hopefully you were able to get all these questions correct, and now if you had some things missing from your notes, you have them filled in. Hopefully I will be back from jury duty on Monday. I hopefully will not get assigned too long of a trial. If I am not here on Monday, I'll have another video for you guys ready to go so that we can continue our learning, and then on Wednesday hopefully I'll be back if I am in jury duty on Monday, and we'll be able to do a lab, a project where we're starting to use the smart rovers a little bit more. All right, have a good weekend. See you.